Alright, so today we're going to be going over the homework questions that I have assigned for you on Daymap. Okay, so for the first bit, we have page 1 and 2, and that's allocated for questions 1 to 3, every second question, question 4, 5, and 6. And for page 3 and 4, I've just allocated number 1 and 5, so I've cut them down. I'm only going to go through 1 or 2 questions from 1 and 3, and the rest of it I'll go through in a bit of detail. So let's start off with question. Actually, I should probably specify here what I'm doing in this video. I'm specifically doing 1G and 1H, okay, because these look the hardest. And this means 3G and 3H as well. Okay, now let's do 1G. So 1G, the question says G is equal to the set such that X is between -3, X and 9. X is a positive integer. Alright, so I'm just going to write this out because that was the part of that. So when we've got this sort of question, what we need to do is we need to recognize that our final answer should look something like this. G equals some set, and we're going to write a bunch of numbers which are inside this set. Okay. Now what numbers belong inside this set? We are given these conditions right here. So this is our condition for set G. Okay. So our condition for set G is that all the x values lie between -3 and 9. But they cannot equal -3 because if you remember from our previous lesson, this symbol means does not include. Okay, so it's greater than -3 but doesn't include -3. Alright, so what are the numbers between -3 and 9 that don't include -3 that are positive integers? Sorry, I do apologize. It's not -3. It's just +3. Okay, so what numbers lie between 3 and 9 that don't include 3? So our answer should look like this. Inside the set G, we have curly brackets, and what are the elements? Well, the elements we worked out were 4, 5, 6, 7, 8, and 9. Alright? And x is a positive integer. This just means we can't have numbers like 4.5, 4.6, 4.7, because these numbers are not integers. Integers, that's pretty much the same as saying whole numbers. Alright, so integers are whole numbers. So in this case, for question 1G, this is what your answer should be. Now, when the question asks you, what is the value for NG? So for example, for 3G, it says, what is NG? Okay, this just means number, sorry, it's not running out. Okay, never mind. Number of elements in G. Okay, so you can see here that there are 1, 2, 3, 4, 5, 6 elements. So therefore, the number of elements inside G is equal to 6. Okay, so this is what your answer should be for 3G. Let's move on to the next question. So your next question is question 1H. Okay, 1H says h is equal to x, such that x can be from -3 to 2 and equal to x can equal to -3, 4, and x is an integer. Alright, so once again, this is what our definition is. X lies between -3 and 4. And if we remember this symbol, this means it does not include. Okay, so what numbers lie between -3 and 4 but don't include -3? So this would be represented as h. The set h is equal to curly brackets -2 -1 0 1 2 3 4. X is an integer. We already know what the definition of an integer is. Integer means whole number. Okay, so we know that's whole number. Alright, so this is just what your answer should be for 1h. Now for 3h, your question is, what is the number of elements, what are the number of elements in nh? Well, let's look at it again. The number of elements in h are, we've got one element here, we've got another element here, 2, 3, 4, 5, 6, 7. So the number of elements in 3h is 7. Alright? So that's the first two questions done. Now the next question, question 5, might be a bit confusing, but it says here, F is the set of prime factors of 210. P is the set of prime numbers less than 10. Alright, so let me just use a different color here because it might get a bit confusing. So, these are our two conditions in this question. Now I'm going to tell you now, question 1 is a bit more difficult, or part 1 is a bit more difficult to comprehend than part 2. So what I would advise you to do when tackling this question is tackle number 2 first. So P is the set of prime numbers less than 10. So P, the set P, okay, let's think of all the numbers that are less than, let's think of all the prime numbers less than 10. So the prime numbers less than 10, we have 2, we've got 5, we've got 7, and sorry, we also have 3. I'll write that in order as well. Okay, and remember what a prime number is? A prime number is a number that can only be divided by itself and 1. So for example, the number 4 is not a prime number because the number 4 can be divided by 2 and that equals 2. Unlike these numbers, okay, they only have 2 factors. 4 has 4 divided by 1, which is 4, so you've got 2 factors here. Alright, so just keep that in mind. I'll rub this out though. A prime number is a number that can only be divided by itself and 1. So let's have a look at this case now. What's 2 times 3 times 5 times 7? Okay, so 2 times 3, that's 6 times 5 times 7. Now let's have a look what 6 times 5 is. That's 30 times 7, and then 30 times 7 is 210. So what we've realized is that when we find the factors of 210, we can say the factors of 210 are, for example, 105 and 2. Okay, we can say these are the factors of 210 because 2 times 105, when you multiply these together, they make 210. But these aren't necessarily the prime numbers. Okay, these aren't numbers that you break down into 105. In other words, 105 is not the prime factor. So if we look at it again, How can we break 105 down? We can break it down into 21 and 5. Okay, so 5 is a prime number, so we can't break it down any further, but 21 is not a prime number. We can break it down into 7 and 3. So you can see what the end result is for this case. The end result is that we have 7, 3, 5, and 2. So in this case, the prime factors for f are 7, 3, 5, 2. And if you look at all the elements in P, 2, 3, 5, 7, 2, 5, 3, 7, you can tell that although they're in different orders, we can tell that the elements of P are the same as the elements of F, so therefore F equals P. Alright. Next question. We'll need to just quickly create a new slide. So next question is question 8. If NA equals NB, then A equals B. Is that true or false? So if we read this out, we should understand this as the number of elements inside A equals the number of elements inside B. Does that mean set A equals set B? Let me give you a counter example. So you've got set A here, and you've got set B here. So I'm going to tell you now the numbers A contain 1, 3, 6, 4. B contains 1, 9, 10, 7. How many elements are inside A? So the number of elements in A, 1, 2, 3, 4. We have 4 elements in A. How many elements are in B? 1, 2, 3, 4. But let's look at the actual sets. A, 1, 3, 6, 4. 1, 9, 10, 7. Are they the same sets? No, they're not the same sets. So therefore, this statement is false. Okay, because that doesn't, just because they have the same number of elements, it doesn't imply that they have the same set. Alright, let's look at the next statement. I should have just created another slide here. Alright, so let's look at the next statement. The next statement says B. The next statement says if A equals B, then NA equals NB. So if the set A equals B, then the number of elements